Good morning, everyone. I am Professor Kamini Subhash Patel, Assistant Professor in Department of Computer Science and Engineering, Data Science at R.C. Patel Institute of Technology, Sherpur. Welcome to today's lectures on language and reasoning models. In this lecture, we will discuss the evaluation of deep learning models using natural language processing. We will understand recurrent neural networks, long short-term memory networks, their limitations, and finally, why transformers have become the foundation of modern large language models such as GPT and BERT. So, let's begin. This course introduces students to modern language models and reasoning techniques used in AI, artificial intelligence. The objective is to understand how machines process humans' language and how recent transformer-based architecture have natural language processing. By the end of this course, student will be able to understand the working principle of modern language model and apply them to real-world NLP applications. Next is the major course outcomes are the course outcome first is apply the principle of transformer BERTs and GPT to develop solution for natural language processing task. Course outcome second is apply pre-training and fine-tuning techniques to optimize language model for practical applications. Course objective third is analyze various evaluation metrics used to measure the performance and reliability of language models. These outcomes focus on applying, analyzing, and evaluating modern AI models. In next slides, now let us understand recurrent neural networks, commonly known as RNN. An RNN is a neural network specially designed for processing sequential data. Example of sequential data includes text, speech, time series data. Unlike traditional neural networks, an RNN maintains a hidden state that stores information from previous time steps. This enables the networks to remember earlier words while processing a sentence. However, RNN have important limitations called the vanishing gradient problem. During training, the network gradually forgets information from earlier part of long sequence. For example, the movie that we watched last week was amazing. While processing the word amazing, the RNN may already have forgotten the word movie. This makes RNN ineffective for learning long-term dependencies. Now next is long short-term memory. It's called LSTM. To overcome the limitations of RNN, researchers introduced long short-term memory or LSTM. LSTM is an improved version of RNN. Instead of relying on a single memory state, LSTM uses three important gates. First is forget gate, input gate, and third one is output gate. These gates decide which information should be remembered, updated, or discarded. Because of this mechanism, LSTM can remember information for much longer sequence standard RNNs. Now next is LSTM improve performance. They still process words sequentially. For example, consider the sentence. The cat sat on the mat. The LSTM process the sentence one word at a time. This sequential processing prevents parallel computations. As the result, training becomes slower, GPU utilization becomes insufficient. Processing very large datasets requires significant computation times. This limitation motivated researchers to develop a better architecture known as transformer. Next is limitations of RNN. Now, let us summarize the major limitation of RNN. First is the vanishing gradient problem, where gradients become extremely small during training. Second is the exploding gradient problem, where gradient become excessively large, causing standable learning. Third is a short-term memory, where important earlier information is forgotten. Fourth is a sequential processing, which prevent parallel execution. Now next is RNN struggle with capturing long-range dependencies in detailed text. These limitations make RNN unsuitable for modern large-scale language processing tasks. Now next, move forward to limitations of LSTM. Although LSTM addresses some RNN problems, it also has limitations. Its architecture is more complex because it contains multiple gates. Running takes more time because of the larger number of parameters. Like RNN, LSTM cannot efficiently perform parallel processing. LSTM are also prone of overfitting when trained on a small data sets. Most importantly, even LSTM struggle with extremely long sequence. Because of this reason, transformers have become the preferred architecture in modern LSTM. Now next is long-term dependency problem. Consider this sentence. The book that I brought last year from the store near my house was very interesting. The word book and interesting are located far apart. An RNN may forget the earlier word before reaching the end of the sentence. Even LSTM may not perfectly preserve this long-range relationship. This is known as a long-term dependency problem. Transformers solve this problem using the self-attention mechanism. Instead of reading word one after another, every word attend to every other word simultaneously. This allows the model to understand relationship between distant words regardless of their position. Because of the self-attention, transformer capture contextual meaning much more effectively than RNN or LSTM. This innovation has completely transformed natural language processing. Importance of transformers. Transformers have become a backbone of modern large language model. Their major advantages include parallel processing of code. Second one is better understanding of large range dependencies. Third advantage is faster training using GPU. Fourth advantage is high scalability for every very large data sets. Superior accuracy across many NLP tasks. Today, transformer architecture are used. GPT model developed by OpenAI, chatbots, sentiment analysis, word model developed by Google, text summarization, question answering, and many more. This concept covered in today's lecture directly support course outcome 1, where students learn to apply the principle of transformers but GPT for solving natural language processing problems. Understanding this concept from the foundation of for advanced topic that will be discussed later in this course. Now next forward to references. The primary reference for this lecture is Natural Language Processing with Python and Spark. Students are encouraged to read this book for a deeper understanding of NLP concept and practical implementation. Dear students, Thank you for attending today's lecture. In this session, we will discuss the working of recurrent neural network, long short-term memory networks, their limitations and how transformer with self-attention overcome these limitations to power modern large language models. In the next lecture, we will study the transformer architecture in detail, including attention mechanism, encoder, decoder, and positional encoding. Thank you. Have a great day.